Hello students, welcome back to my channel Infinity Minds where maths is made easy. Today we shall be doing class 9 mathematics Ganita Manjari's chapter number 4 exploring algebraic identities, end of chapter exercises. Okay, we shall be taking up the first 4 questions in this video and the rest I'll place in the next video. Let's begin. Question number 1. Use suitable identities to find the following products. Children, in the end of chapter exercise, as we know, we have already completed the topic with all the concepts that were required. As such, it is only repetitive questions are there to practice. So, you won't find much difference in them and you won't find them very challenging. Few are that I shall be separately dealing with it. As of question number 1 is straightforward identity based. Using suitable identities, we have discussed it in the previous videos also. Whichever identity you will apply, since they have not told, that will have to be mentioned. That we will clearly mention. Like it is very evident, this is addition of two terms. So it's an a plus b and there is a bracket around that. So a plus b whole square. Okay. A plus b whole square. What does the identity say? Square of the first term. So minus 3x will play the role of A and 4 shall play the role of B. Square of minus 3x, minus 3 into minus 3 is a plus 9, right? Which will be x square. Square of the second term, 4 square 16. Plus, as it is a plus, there would be a plus twice the product. Where the first term itself is a minus 3x. So 4 into 3, 12 into 2, 24 with a minus. So a minus 24x shall come and this is done. There is no further simplification that is needed as they are all unlike terms. Power 2, power 1 constant. Clear? Going to the second part of the question, 2s plus 7 into 2s minus 7. Children, without looking at the answer, first you must try all these questions by yourself as it is addition and subtraction of the same terms. I mean, you pick up any two terms and those same terms you are first adding, in the next bracket you are subtracting. So it will follow the identity of a plus b and a minus b. You have to have your identities by heart. I shall be sharing the chart of identities with you to get as lump sum. If you wish to receive the PDF copy, please comment in the box and I shall mail you the slide for the formula. Okay, all the identities that you have, that I will mail you personally. If you notice, you will have to see that it is a plus b into a minus b. So the identity form, hence it becomes a square minus b square. Here 2s is my A and 7 is my B. Don't get confused with the sign. That sign is of the formula of your identity. Square of 2s, square of the first term minus square of the second term. Okay, minus will get taken care in the identity itself. 2 to the 4, s square minus 49 and this is done. Clear? We'll go to the next. Part number 3. P square plus half, P square minus half, again a plus b into a minus b, a square minus b square, square of p square, p to the power 4, square of half is a 1 by 4. Minus will come as part of the answer. Next, part number 4, 2n plus 7 into 2n minus 7, again a plus b into a minus b. Square of 2n, that is 4n square, square of 7, that's a 49, 4n square minus 49. A square minus b square. The more you practice writing your answers, children, you will get used to. You will be easy. It will be easy for you. Some of you even get confused with this. You get confused. Sometimes you are meaning this, but you are writing this and vice versa. It is completely different. These are completely different. This is your A plus B. The LHS is your A plus B whole square thing that we are talking about. And this is A square and B square. Squaring the terms individually and adding and squaring are completely two different facts. Okay. Make sure you are clear of what you are being asked for. But I'm sure those who watch the videos of Infinity Minds and practice thoroughly won't have any problems. 4n square minus 49. I hope that's clear. We'll move over to the fifth one. Try to see a minus b. If it is, we're just trying to work out a square plus b square plus 2ab. If I try to see, yes, it is working out as a minus b. If s plays the role of a and 2t plays the role of b, then it is able to form this particular, it is resembling. You are subtracting those two terms, then you are doing the squaring of these two terms, as 2t square will be 4t square plus the product of s and 2t, that is a 2st. Yes, so this is nothing else but your identity of a cube minus b cube. Remember, we had studied the identity as a cube minus b cube. We just learn, okay, a cube minus b cube is a minus b into a square plus ab plus b square. Most of you must have learned also, but learning and applying are two different facts. Application is your practice. You are being given this, you have to realize that this is being asked, okay. Once you are aware, then it's hardly a question. So what will it be? It will be square of s cube as square of a, the first term square, minus square of the second term. But 2t square, cube of the second term, 2t cube is going to be 8t cube. S cube minus 8t cube. Clear? Cube of the first minus cube of the second. Okay. Practice will help you a lot. Okay. In fact, all these questions which I am discussing right now are most simple, I would say, for class 9. They are direct identity application. Okay, no problems. We'll go to the next part, number 6. Try to see a minus b whole square. Direct a minus b with 1 by 2r playing the role of a and 4r to play the role of b. You don't even have to think. It is one term minus the second term whole square. Direct a minus b whole square's identity. Clarity of a and b, the first and second term should be very, very clear, as you would, the further part is dependent on it. Square of 1 by 2r. So when you do the squaring of 1 by 2r, you would get 1 by 4r square. 1 square will be this. Numerator is squared, denominator part is squared. 1 by 4r square plus the square of the second term. 4r square will be 16r square. Square of 4, square of r. When you do 4r whole square, it is, one has to actually write individually the square of each. I just specially explain each and every minute point also, which may be a point of doubt in someone's mind. You know, even if in one child is not clear, I would like they should become proficient with the basic concepts of maths. Minus 2ab, yes, no need to skip. You will work it out, as especially there is a fraction. Minus 2 by r into 4r. 2 cancels with the 2, r cancels with the r. Minus 4 is left. Nobody is giving you any word to do it mentally. Do one step extra, but do it correctly. Okay. Going to the next. A plus b plus c whole square. Yes, we will call it a plus b plus c, children. There is no need for you to devise any new identity. A shall take up a negative value, no problems. C is going to take up the negative value. No one is asking you to have. This is an L. In the print form, L comes like this. This question I have taken up from Ganita Manjari only. The print comes like this. In the text print, second term, of course, must not be a problem. First term, second term, third term. After all, it is nothing else but a minus 3m to be added to a 4k to be added to a minus L. Okay, it is like this. A plus B plus C. C taking a negative value, no issues. What does A plus B plus C whole square identity says? A square, B square, C square, 2AB, 2BC, 2C. Clear? Square of the first term, minus 3m whole square, 9m square, 4k whole square, 16k square, minus L shall become a plus. as minus even number of times becomes a plus L square. 2ab 4 is a 12 minus 24 mk. 2 into 4 8 minus 8 kl minus minus plus 3 2 is a 6 ml. Done. And we leave our answer here. Yes, it will contain 6 terms. You remember there used to be questions. Even the reverse is there. When you have this form and you have to reach. That also we have practiced in the past and we'll be doing again. So identities are applicable both ways, children. You must practice it both ways. One is for you, it's like in your word terms, it is like direct a minus b whole square. The other is when the answer form is given, you have to reach. When it says factorize or find factors or anyways, even if it's simplify for you, yes, either ways it can be asked. You must learn your identities properly. Coming to the last two parts of the first question. A minus b, x will be by a. What will play the role of the second term? 1 by 3 y or y by 3. These identities carry your a plus b, a minus the whole square identities and the whole cube identities. They are available in the minus form also. Okay. See, they are available in the minus form also. So when you apply, then you can take the value of the second term as positive as the identity carries minus with it. The ones where we have not done, there you put the minus with the second term. Same thing we can solve as this also. I've seen some students getting confused. Try and see, children. I can apply my a plus b whole cube identity also. Then my b shall take the value minus y by 3. And then you can apply the formula identity of a plus b. Use this, then give the value of b negative, like we did in the previous one. A plus b plus c whole square. We have applied the identity of the positives. The terms were taking negative values. Here it is vice versa. If we have a ready-made identity a minus b whole cube, the b is positive in this case. Minus is getting taken care in the identity. Okay. Just be very clear on these concepts. So as of our b becomes positive y by 3 and the identity shall take care of the negative sign. So a minus b whole cube identity should be very clear. If that goes wrong, of course, what will you apply? Okay. A cube, your way of learning, like I'm used to learning the way I've learned in life. A cube minus b cube minus 3a square b plus 3b square a. Yes, kind of. I have marked up at my time. No problems. You may also do the same. Whichever is your way of bugging up. A cube minus b cube plus 3a square b minus 3b square a. Plus 3. And the other one is where you take 3ab common. That form also we had done. So that's up to you. Anyways, now let me erase the extra part so that you can concentrate on the answer which is there. Square of the first term x cube 1 by 3 minus y by 3's cube. This is x cube, y cube, 3's cube will be 27 minus 3a square x square y by 3. Try to see minus 3a square minus 3a square b minus 3x square b is y by 3. 3 shall cancel with the 3. So minus x square y will be left. Right? And similarly 3x y by 3 will be squared as per the identity y square by 9. 3x will remain as it is 3ab as in 3a and the second term y by 3 will be squared, that is y square by 9. 3 to 3 it would be x square, xy square by 3, that's a 1 by 3. Or somebody may write it like this. The way it has been written here, 1 by 3 xy square. These are all separate terms. No, there's nothing like further simplifying. They are four separate, it's an polynomial containing four terms. X cube, y cube, x square y, xy square. Just that they were fractions, so you have to make sure you apply the identity. Calculate and work it out. It is not difficult. A minus b whole cube, again 7 by 2k is your A, and 2m by 3 is your B. So cube of 7 by 2k, like basically it is being calculated in separate steps because there's all are fractions. 7k's cube would be 7 cube is 343k cube, 2 cube is 8. 3a square 7k will become 49k square by 4 into 2m by 3. When you simplify, you get 49k square m by 2. 3 7k by 2 and 2m by 3 whole square will be 4m square by 9. So on simplifying, you get this. This is of course be 2 cube will be 8m cube. So our answer is this, sum total of all of this, nothing else. Individually, basically terms have been found. Just because it was slightly complicated, it is up to you. This is also the way. Either you solve it there itself horizontally, or you solve the four terms which are required separately and then just frame your answer. Okay. So that was the end of your first question. Each of the question has a lot of parts in it. Okay. But none of them are difficult, I would say. The first four questions are very, very simple if end of chapter exercise. Let's quickly start with the second one. Find the values using identities. Now see, identities are applied to numbers also. 17 and 21. Like when you have these two numbers multiplication, we have to try and think of a connecting number in between. Like here, 19 can be termed as it is at equidistant. It is equidistant from the two numbers given. It is at equal distance from 17 as well as 21. Okay. So at a difference of 2 units from 17, 2 units from 21. 17 could be expressed as 19 minus 2, 19 plus 2. So now it reaches the form of a minus b into a plus b, square of 19 minus square of 2. 361 minus 4, 357. 104 plus 96. Can you think of a number which is at equal gaps from all of these? Like if one plays 96, 104, 104. Oh, I have placed the number line the other way. I'm so sorry. As if we do for integer, negative integers. So I was just trying to show that if there is 96, then there is 104. So the equal gap would be 100. So 100 minus 4, 100 plus 4. So a square minus b square, 100 square minus 4 square. Easy numbers to deal with. 10,000 minus 16. Clear? We'll go to the third part now. 24 and 16. 20. Very, very repetitive, children. In fact, I would suggest before you go through, just pause the video and first solve it on your own. 20 plus 4, 20 minus 4, 20 square minus 4 square, 400 minus 16, even the values, calculation, everything is very, very simple. 147 cube, nothing like a cube, children. It's nothing like this. You have to break the given number as one of the ways. Either a plus b whole square, it's a cube, sorry, okay, or a minus b. Same thing comes with square also. If it is not told, it is your wish. Logically, it is closer. If you estimate it, it's closer to 150. So expressing it as 150 minus 3 is sensible enough. 150 minus 3, it takes the form of a minus b whole cube. This has to be a minus. The wrong identity has got printed. Okay. I'll just rewrite it. A minus b whole cube, a cube minus b cube minus 3a square b plus 3b square a. We just write it down for you in a black pen so that you are dark. This is black. I'll take. Okay, let's try and write the identity now. A minus b whole cube. Using the identity a minus b whole cube, we are doing cube of the first term minus 3a square b plus 3b square a minus b cube. Okay. Yes, little calculations needed at this point. 150 cube. It's so how what's the trick to do 150 cube, children? Nobody should be getting hassled with the I'd like to choose the thicker one. With zeros, it is the 15 cube that you have to think. Children are expected to know first 20, 30 numbers, squares and cubes. Yes, you must learn. 15 cube is 3375. A single zero cube will result in 3 zeros. Minus 3 3s are 9. 15 into 9. 2025. A single zero will become double zero. 3 and 3 square is a 9. 15 9 times 4050 minus 27. This is what we reach. Okay. 199 cube closer to 200. 200 minus 1. Again a cube minus b cube minus 3a square b plus 3b square a. With 200 playing the role of a. You are only going to concentrate on doing 2 cube. That's an 8. And double zero will become 3 times. 3 into 2 zeros are your 6 zeros you are going to place. 2 twos are 4, 3s are 12 and 4 zeros. 3 twos are 6, 2 zeros minus 1. Simple. 127, 130 minus 3. Same repetitive, children. You can go through it yourself. First try it out and then match the answer. Okay. Yes. This can still be considered slightly different. Minus a cube. Yes, we haven't done minus a cube. Try to see it's a minus 1 into a. So it won't be wrong. The power is with both of them. The power is for the minus also, 107 also. There's nothing called minus. It's a minus 1. We term it as minus 1. So power 3 is with both of them. And if an odd power is applied to minus 1, it will come out to be minus only. So it is sensible to take the minus outside. Okay, I have just explained in this whole manner why minus has come outside or how has it come outside. The cube is with the minus. Minus means minus 1. Cube is with minus 1 also. So if 3 times minus is done, we get the sign remains to be minus. So we can just easily keep it outside and now just concentrate on 107, which is okay if you represent it as 100 plus 7 with a minus to be kept. Minus shall come in the answer eventually. Okay, so 100 plus 7 is one way. The way we have done previously, I could have rounded off 107 to 110 also, and doing it like this would have also been correct. Okay, it's not wrong. Just that, I mean, if you see comparatively, dealing with 100 is certainly preferred. There wasn't much choice. If you were dealing with 147, the choices were 150 minus 3 and 140 plus 7. So it is not something a great choice. This was equally possible. So it was sensible that where it is logically getting rounded off to, you choose that path. Here, choosing 100 is comfortable. Even if you are making it go back, no problems. Okay. Just sharing my piece of thought. So a plus b whole cube, cube of the first term, cube of the second term. Cubing, 2 zeros will become 6 and so on. 3a square b, 3b square a. Identity should be clear. Everything done, but in the answer, affix your minus. As we began our question with the minus. Okay. All the extra marks I could take away so that you can concentrate on the answer. Clear, students? Like this, you will not find any question difficult, especially when you go through the videos of Infinity Minds. Moving over to the next one. Minus 299. Similar thing now, same. Minus 299, students, minus will come outside minus odd number of times. Had it been even, the minus would have become positive only, in fact vanished. So minus is outside, 299 is 300 minus 1, a minus b whole cube identity. A cube, 3 cube 27, zeros, b cube is 1 only, 3a square b, 3b square a, answer carries a minus. Now we start with the third question. Factor the following. What I was just discussing a few minutes back. That factorize, like your answer form of the identity is given. You have to move backwards. We shall, yes, children do find this slightly challenging compared to the ones where it is directly a minus b, a plus b whole square cube. 4y square, is it a square of any term? Yes, 2y. 1 by 16 y square. 16 square root could be 4. Y square can be written as square of y. So y by 4. So sorry. Y square is in the denominator. It is a 1 by 16 y square. So 1 remains as it is. 16 can become 4. 1 by 4. How many of you are clear of both of these? I keep discussing certain tricks which you won't believe. Even children grow up, but they grow up with certain, confusions. They just pass on from one class to the other. This and this, they are both same. Whether you put the round bracket around only the denominator or whole, both ways it's the same. Okay. So we move over to the next step now. Yes, this is 2y whole square. This is 1 by 4y whole square. Can it be written, can 1 come as the product of the 2ab form? Because we are used to this identity. 2 brackets 2y, oh not brackets, 2ab, and b is your 1 by 4y. 2ab, if I express 2 2s are 4, cancels with this, y cancels with this. Yes, if I write a 2ab, my answer is coming 1. So it is fair enough. This can be expressed as a square. This, if I take this as b square, the 2ab is definitely giving me 1. So it is going to this form. That is a plus b whole square. So simply take up these two, a plus b whole square, and just write it a plus b whole square. The identity that you have. Okay. We'll go to the next. We have no choice, but it must be a square minus b square. This, I mean, nothing else is getting spoken. I mean, if you remember the identities. So, but are they square terms? You'll have to calculate their square roots. Square root of 9 will be 3, m square will be m. This can be 1 by 5m. Is, if 3m let 3m play the role of a minus b, a square minus b square. So a plus b, a minus b. Pick up the term inside the bracket and add them, subtract them. You don't have to think what will come. Just leave it. They are separate. 3m plus 1 by 5m. Bas. Unlike terms, let them remain as it is. A plus b, a minus b. Clear? Next. See, before looking at the answer, all of this, the video that I've putting up today is absolutely self-practice. All the questions I would suggest first you practice. After that, even if you switched on the video, close it. First practice the first 4 questions on your own, then match the answers. Okay, coming to the third part. If I call it a cube minus b cube, yes, I must see that is the only form it can resemble. Identity should be on my tips. A minus b bracket a square, b square. But who is going to play the role of a? The cube root of 27 b's cube. The cube root of 27 b cube. It is like you have to do this. Nobody writes it. Cube root of 27 is 3. Cube root of b cube will be b. 3b shall play the role of my a. 3b minus 1 by 4b. Brackets. Square of 3b, 9b square. Square of 1 by 4, 1 by 16b square. And this is an AB. So 3b into 1 by 4b. The product. B cancels with the b and only 3 by 4 is left. Okay. All this is more clear when you do it with your own hands. As you practice, in case you made an error, yes, cross-checking can help you. You are stuck or your answer is not matching, just see where you are stuck. Speaking and looking at the answer slide may confuse you, make you feel underconfident. First you solve, then you match your answers. Going to the fourth one. Yes, you remember the last slide, quadratic. The quadratic equation that we had studied. I'll write it once again. It is resembling the quadratic form. As you get something to factor, what was the terms, conditions I had given? First, think, is anything coming common? The previous one also, nothing was coming common. And second, you have to check, are they square values? And now even cube values you have to check, because we also did. So whatever you check, but none of them will work out. You will see, fine, this can be square value, but this won't. Even if the second one is, the in between won't match. You must make sure each of the term, okay, just in case, one rare chance happens that both square values, then basically if it doesn't match, you must make sure. You should not blindly apply that, okay, I feel it's an a plus b whole square. No. So we need to remember that type, x square plus ax plus b, whichever way, two terms whose sum should be. And what was the another name I had given to this? Splitting middle term. Remember, students? Splitting middle term. We want to get two factors such that this is initial for such that, not much emphasized at school level. But yes, later we do use two factors such that if I add, I get A, and if I multiply, I get b into 1. If there is a coefficient, that is taken care, okay? So we need two numbers such that sum is 5 by 6, product is 1 by 6. Yes, this can be termed as slightly challenging for you to think. Slightly, I would say. Slightly challenging. Why? Because you have to think of these two factors such that you get a 1 by 2 and a 1 by two factors. So how would you think? That is your slight challenging part, because we used to do prime factorization to 1 by 6. Okay. So factors of 6 are 2 and 3, and that matches with 5. Now if you take a 1 by 2 and a 1 by 3, if I do the product, yes, I get a 1 by 6. And if I add 1 by 2 to 1 by 3, how do you add fractions? LCM is 6, 2 will go 3 times, 3 will go 2 times. 5 by 6. That's what we wanted. The sum to be 5 by 6. Product, of course, is a 1 by 6. So splitting it as 1 by 2x and 1 by 3x. Take common from the first two terms. X is common, x plus half. Next two terms, 1 by 3 is common, x plus 1 by 2. there would be a repeating bracket. Remember, I had explained all of this in the previous slide video, and if you haven't watched, you must go back and watch it. So x plus half will come outside common, and x plus 1 by 3 in the inside bracket. Okay, try it out. We'll go to the fifth part. Try to see a cube which can be the b cube term here. Okay, try to see which one is the b cube. Is it? But anyways, this is a cube. So that is for you to work it out. But yes, because after that, it would be minus 3a square b plus 3b square a. It is for you. You must be very clear of your a and b. Try and see cubic. 27 is cubic. Any other cubic? 27 is there, but then u square by 5 is not. I mean, u square can't be a cubic term. U, 9, 25, they are non-cubic. This is cubic. We never know how they arrange the terms. Most of the questions we were getting b cube in the last. So don't think in that manner. You have to check out for the cubic term. Yes, 125 is a cube. You have cube root to 125. That is 5. So clarity of our two terms should be there. A would be your 3u shall play the role of a. 27 cube root 3. U cube will be u. And who will play the role of b? 1 by 5. And now it's not much. Now it's straight away a minus b whole cube. You can just write 3u minus 1 by 5. But that is as simple as, because the answer is being flashed in front of you. Try and see. I was talking about how you will actually, your mind will work. So I was only guiding on those terms. A cube minus b cube, because many children arrange the term, minus 3a square b. My emphasis is on this term, this particular solving. This particular step basically. You must have this. That 27 is being written as 3u whole cube. This is 1 by 5 whole cube. 3a square b form. Is it matching this? Plus 3b square a. Okay. What I'm trying to say, how you think I can guide, but it is for you only to think. Okay, my main emphasis is thinking on this. Why am I emphasizing so much? As this will make you this 3a square b, 3b square a, and then cross check, is it matching or not? Then writing answer is not a problem. Identity you remember, just write a minus b whole cube. Done. It's like your answer form is already given. You have to reach the question form. No, we are working backwards. Part number 6, 64 y cube cubic term, a cube plus b cube very clearly, where 64 will be 4, I mean cube root of 64 will be 4, y cube shall become y, 4y whole cube. I'll change the color of the pen. 1 by 125 z cube or z cube. I think that has been now. So, okay. A cube plus b cube. Yes, they are quite troublesome identities. Couple of them which you need to learn. Do ask for the PDF chart. Okay, I would love to share it with you all. A cube plus b cube, a plus b bracket a square minus ab plus b square. Very clear on who is going to play the role of the a and b, first and the second term. 4y and Z by 5. I can leave this much to you. We've repetitively practicing. Coming to this one, this identity we haven't practiced. Again, the way I was telling in the previous one, fifth part, try to identify the cubic one. A cube, B cube. Okay, this is your A cube and this shall play the role of B cube. This is your C. A cube plus B cube plus C cube. Then the identity is this minus 3ABC. Is it minus 3ABC? That will give us the step I have been emphasizing on, right? Minus 3 P 27 cube will become 3 cube and the R. 3 threes are 9 P Q R. Yes, it does resemble A cube plus B cube plus C cube minus 3ABC form, children. It does. So what does our identity says? A plus B plus C bracket A square. Once your ABC are clear, I hope now you people are used to how to identify. I've emphasized a lot in this slide. Questions being repetitive. I have shown you the path how to think on the cubic, how to decide which term is to be taken, who is going to play the role of your ABC and so on. A plus, once your ABC terms are clear, A plus B plus C, A square, 3Q square, R squared, minus AB minus BC minus CA. That this would be 3PQ, 3QR, 3P. Loads of questions, loads of subparts in these questions, okay? Part number 8. And making you think on all possible identities. The 8, 9 identities you've got, it's a very good practice. Sometimes it is cubic, sometimes it is A plus B plus C whole square. Now it is back to some old class 8 level of A is 9m square. Yes, that's a square term. 12m is not a square term. 4 is a square term. So A square, B square, minus will be written as it is. Can 12 be written as 2AB? This is the step that I have been emphasizing on. In smaller questions, it doesn't matter to you, you don't feel, but otherwise it is. This is the one. Okay. So A minus B whole cube, A minus B whole square, 3m minus 2 whole square. A cube, 9 is a cubic term. This is like your previous one, what you just did before. They have only jumbled up the parts. So part number 7 is same as 9. A cube minus B cube, A cube plus B cube plus C cube minus 3ABC. Try and see, children. Again, that logic of plus and minus that I've been emphasizing. If the identity says plus and minus, if the identity is made up of plus, we shall take the value of B as minus. Okay. A plus B plus C and so A cube plus B cube plus C cube minus 3ABC. I am doing quite a lot experiment with this. I better shouldn't. So let me just write what I wish to tell you all. And you can mark it in your textbooks, children. So that when you are revising, it is the difficult ones which you need to emphasize slightly more. It is obvious. You are students after all. It is okay if you tend to forget, but practice shall make you perfect. Ninth part also I will term it as challenging. So taking 1 by 3 common, as you will not be able to make it, otherwise 3ABC will not work out. So taking 1 by 3 common, (27) x cube will come inside. If you will take 1 by 3 common out of 9, 27 will come. As all they both were having 3 in the denominator, 1 by 3 has been taken out common. But in Out of 9, if you take out 1 by 3, see, presence of a bracket is multiplication. So what do I multiply 1 by 3 with? That I get a 9. You're getting my point? What we want to take 1 by 3 common out of 9. 1 by 3 into something has to give me 9. So that something has to be 27. 27x cube minus, so 1 by 3 goes outside, minus 8y cube left inside. Again 1 by 3 goes outside, z cube is left inside. And see, if 1 by 3 goes from 6, it's like a product, children. So if 1 by 3 goes outside, what do I multiply 1 by 3 with to get an 18 as to get a 6 as my answer? You want to have 6, you are taking 1 by 3 common, so you have to place 18 as 1 by 3 into 18, 3 6 are 18. If I open the bracket, 1 by 3 will multiply with 18 and we will reach 6. Okay. Now 27 is nothing else but cube of 3 to be added to, minus will be taken as part of b. So 8y minus 8y cube will be minus 2y whole cube z cube minus 3abc. Now I am able to make it resemble this particular form. Okay. Now it is able to come. Hence we will apply our identity now with 1 by 3 separately outside. So taking this 1 by 3 was the only challenge I was talking about, and what to write inside is also there to be emphasized. Now a plus b plus c with minus 2y playing the role of b, a square plus b square plus c square minus ab minus bc minus ca. Kindly note, minus AB has minus BC minus CA. All of this, I can leave it up to you. You can certainly solve. This is hardly anything now left. Minus minus plus 6xy minus minus plus minus 3xz. Okay. So, 10th part. 2x whole square, 9y, 3y whole square, 36, 6z whole square. A, B, C. A square, B square, C square. 2AB. Now you just write and see. Yes, it is matching. 2BC, 2CA. A square, B square, C square plus 2AB, 2BC, 2CA is A plus B whole square. So just have your answer. These are the usual one. Where it is tricky, I'll let you know. Okay. Again, this one we have done a lot in this video. A cube minus B cube. Who will play the role of B? A cube, B cube. Let me write down. This is my A cube, this is my B cube. Okay, then minus 3A square B plus 3B square A. So try and match. A is going to be your 3U and B is going to be your 1 by 6. Of course, 216 cube root is 1 by 6. The more you learn certain things, they're going to help you, children. Minus 3A square B. 3B square 1 by 6 square 3u. Is it matching up to that? Yes, it is matching up. So answer will become 3u minus 1 by 6. A minus B whole cube. Clear? Done? We'll go to question number 4. Now simplify the following. We have done this type also in the 5th exercise, children. Basically, it is factorizing. It is completely, the way I had told you, this one takes care of all the previous. They are individual. This is completely by yourself. It is not even telling you find factors or factorize, but on your own you have to see. You cannot divide two expressions just like that. No, not at all. 4x square, very, very common expectation, very, very common thing which students genuinely believe. If you, I'll just show you something. Honestly, see how many of you believe that you actually feel, yes, that's correct. I will also do the same. Ask yourself. that start solving without looking at the answer. So many of my lovely students, all my students are very dear to my heart. Cancelling. Wow, somebody may feel even one could cancel. No, please, no, no such thing is going to happen, students. Please let it remain on my slide. Let me not erase this. You please erase it from your mind that this is not to be done. This is never to be done. Okay, so coming to 4x square, a square, this is not a square term, but 1 can be written as 1 square. A square, b square, 2ab. Very, very simple. A plus b whole square with no challenge. Positive integers, not even fractions, nothing to trouble you. The thing is, you have to think on your own. It's an a plus. Which identity is it matching? So, and 4x square minus 1. Try to think. A square minus b square. At least try. If it does it, sometimes it doesn't. So it is, no, see, you could have those who feel they require, they can do this thing. 4x square is 2x whole square minus 1 whole square. Using the identity a square minus b square. Oh, I think that I haven't written. I forgot to write. You may write, please. Using a square minus b square, a minus b into a plus b. So 2x minus 1 into 2x plus 1. So these are my two things that I am going to make use of. Okay, these are my two things. This and this. They are supposed to divide each other one upon the same order. This will come in the numerator, 2x plus 1 whole square, and this is going to come in the denominator. It is but obvious that one time it is going to cancel. Sometimes cancelling is, as you grow, you should know. Power 2 means it will come 2 times. One of the times I have cancelled. So 2x plus 1 upon 2x minus 1 becomes my answer. It is much simpler than those long identities, isn't it? But children find it okay. You have to start thinking on your own. The starting of the question is self-thinking, but solving wise it's much easier. Don't feel afraid, okay? We'll go to the second part now. Oh, okay. 9 3a cube minus 24b cube upon 9a square minus 36b square. 9 is taken common. A square minus 4b square, that is a whole square minus 2b whole square. Clear? 9, where are we? For this one, it becomes a whole square minus 2b whole square. So a minus 2b, where is my pen? I'm so sorry. A minus 2b, a square minus b square, a minus b into a plus b. A minus 2b into a plus b. And the numerator shall become 3 times a minus 2b bracket a square plus 2ab plus 4b square. Now cancelling the common factor a minus 2b. It is coming in the numerator as well as denominator. Okay. This can be slightly challenging for you. This also you mark and practice it once. Okay, as you have to take common also. This is a cube minus 8b cube. So that is a cube minus b cube formula that we apply. A minus b bracket a square ab b square. Going to the third part, a cube plus b cube identity. Okay, straight a cube plus b cube identity. A plus b bracket a square minus ab plus b square with 5t playing the role of b. And denominator is your splitting middle term. But yes, so this part is challenging for you. What I'm writing challenging, you must re-practice it once, for sure. For sure. This is s square, this is t square. So 35 factors you will calculate. You just have 5 and 7. So minus 2 is to be split up as minus 7 plus 5. You take common. Repeating bracket comes outside. 7 s plus 5t comes inside. So the challenge was the usual quadratic form was not there for you to identify. Okay, the usual quadratic form ax square plus bx plus c. The constant is not there like in the usual way. Okay. So now the given expressions, you just have to put these two terms, numerators and denominators together. This one and this one. You can see this would cancel with this and the rest will be left. S square minus 5s plus 25t upon s minus 5t. I have just shown the way you will place and you will cancel. Okay. So with that we come to the end of the first 4 questions. Do like and subscribe to the channel and keep watching. And keep watching for more informative videos. Soon I'll be putting up the rest of the part of the end of chapter exercises. Okay. Thank you everyone. Thank you for watching.